Hi everyone! I would like to welcome you to another session on General Chemistry class. This is Teacher Grace, and I will help you walk through to a more simplified discussion. Today's topic is all about writing chemical formula of common chemical substances. And it is more important to know what do we want to achieve by the end of this course. So we set our objectives. One is to know the basic rules in formula writing. Two, recognize the formulas of common chemical substances. And three, compare consumer products on the basis of their components for use, safety, quality, and cost. Now, what is a chemical formula? Do you have any idea? Well, a chemical formula is a shortcut representation of the group of elements chemically combined together to form compounds or new substances, and it is represented in symbols as well as subscripts. What are these symbols? These are the first letter or first and second letters of the names of the elements that makes up the compound. Or sometimes it is the first two letters of the Latin names of the elements that makes up the compound. Where can you get this? You can check this on your periodic table. Actually, you don't need to memorize all of those, but you have to familiarize yourselves with the common elements. How about subscript? These indicate the number of atoms of the elements present in. Where can we get this? We will find out as we go along. Now, here are the examples of some common chemical compounds. Let's start with sulfuric acid, which is also known as hydrogen sulfate. It is represented as H2SO4. Notice that there are subscripts here and also here. But never mind about that for now. Di na siya naghalin. Ato na siya karon hibaluod as we go along. Well, anyways, this type of chemical compound is very dangerous because it's extremely corrosive and toxic. It can cause irritation and can lead to death if swallowed or inhaled. Let's go now to carbon dioxide. Carbon dioxide is represented as CO2. As you can see, there is also a subscript here. But never mind that for now. Let's see kung di na siya naghalin later on. Okay, so carbon dioxide, may I ask, is it good or bad? Some of you may say it's good, and some of you may say it's bad. But here's the big important thing about CO2. It is a greenhouse gas, right? And that means CO2 in the atmosphere works to trap the heat close to Earth. It helps the Earth to hold on to some of the energy it gets from the sun so that the energy doesn't all leak back into the outer space. And if it weren't for this greenhouse effect, Earth and the ocean would be frozen solid. Earth would not be the beautiful blue and green planet of light that is. Can you imagine that? Now let's go to sodium chloride. Sodium chloride is represented as NaCl. Have you noticed that there are no subscripts found? Naaayahan. We will answer that as we go along. NaCl is also known as your table salt. And syempre, luwas na mahatag siya sa sabot sa pagkaon, or it may help you preserve food like fish or your meat. It is also essential compound to our body in absorbing and transporting nutrients, maintaining blood pressure, maintaining the right balance of fluid. Let's proceed to the very basic steps in writing a chemical formula. First, we have to know the chemical symbol for each of the elements, and we have to know the element's oxidation number. We don't need to memorize all of this, because you can find all of this information that you need in writing a chemical formula on your periodic table of elements. You just need to familiarize yourself using this. In forming new compounds and substances, elements involved tend to gain, lose, or share electrons during bonding. And this is something to do with their oxidation states. And this oxidation state are represented by the element's oxidation number, which you can check out on your periodic table. And it's important to know if an atom loses or gains electrons when combining with other atoms to form compounds. But how do we keep track of the electrons lost or gained by an atom? We do this by looking at an atom's oxidation number by referring to your periodic table. And that this oxidation number could be positive, negative, or zero. In short, this oxidation number can help us track which element is the electron giver and which element is the electron receiver. Refer to this periodic table. Elements which belong from group 1 to group 12, except for lanthanides and actinides below, are metallic elements. Well, by the way, group numbers are those vertical columns on the periodic table, while periods are the horizontal ones. And those elements listed under group 13 to group 18 are non-metallic elements. However, these elements belong to the grayish section are considered metalloids because they have the characteristics of both metals and non-metals. And it is so important to refer to your periodic table because such arrangement has much to say, especially in setting some rules concerning oxidation number. Now here are some rules concerning oxidation number. Make sure you have your periodic table with you so you can go over through it. Rule number 1. All elements in their natural state have an oxidation number of 0. Yes, that is true. All elements listed on your periodic table are in their stable state. That's why their oxidation number is 0. Even though there are elements which exist in diatomic form like nitrogen, oxygen, and hydrogen. Rule number 2. Group 1, 2, and 3 atoms in compounds are always positive 1, positive 2, and positive 3. Let's take this for example. Unless in its pure elemental form, the oxidation number of metal in group 1 is +1, as well as in group 2 is +2. But it is important to note also that although hydrogen is in group 1, hydrogen is not a metal, right? And so hydrogen is not included in this rule. Let's proceed first to rule number 3. Fluorine. Fluorine is always -1. Fluorine in any compound, it is -1. A few examples of fluorine-containing compounds are hydrogen fluoride or hydrofluoric acid, also sulfur hexafluoride, and sodium fluoride. Now let's go back to hydrogen. Why hydrogen is exempted to have an oxidation state of +1 together with the metallic elements in group 1? Because hydrogen exists which has the oxidation number of both +1 and -1. It is -1 when it is bonded to a metal. For the compound sodium hydride, hydrogen is bonded to sodium, which is a metal. Therefore, its oxidation is -1. But when it is bonded to a non-metal, the oxidation number of hydrogen is +1, like for example, hydrochloric acid. However, oxygen has 3 possible numbers, such as +2, -2, and -1. In general, oxygen oxygen has an oxidation number of -2, and the only exceptions are peroxides, where oxygen has an oxidation number of -1, and in the compound of oxygen difluoride, where it has an oxidation number of +2. For the other halogens like chlorine, bromine, and iodine, the usual oxidation number is -1, except when they are combined with oxygen or chlorine. In the compound sodium chloride, the oxidation number of chlorine is -1. And in the compound hypochlorous acid, the oxidation number of chlorine is +1. And in the compound perchloric acid, the oxidation number of chlorine is +7. However, the sum of the oxidation numbers in a neutral compound is equal to 0. Take this as an example. Do you know what this is? It's a water molecule, and it's an example of a chemical formula. And every chemical formula has a positive half and a negative half. Buod silingon, for every chemical formula, may ara gid ginatawag nga positive ion, kag may ginatawag gid nga negative ions. Hindi pwede nga ang positive kag positive ions ma-form compound, kag ang negative ions ma-form compound. There should be positive half and a negative half. And the element with a positive oxidation number is always written first. Like for example, hydrogen. Its oxidation number is +1. It's called a cation. And the element with a negative oxidation number is always written second. For example, oxygen with an oxidation number of -2, and it is called an ion. These two will react and be bound together in forming new compound called water, right? In this case, hydrogen do not give off electron, as well as the oxygen do not receive electron, but instead they both share to make themselves stable. And this is an example of covalent bonding. Let's proceed to another example. Look for potassium on your periodic table. It's a metallic element, so therefore you can find it on the left side. Okay? So potassium is K, and its oxidation number is +1, right? Look for chlorine. Chlorine is a non-metallic element. It's a halogen. Therefore, you can find it on the right side of the periodic table. Okay? So chlorine is Cl, and its oxidation number is -1. So how do we write this? Of course, first, we have to write the positive ion first, followed by the negative ion. So therefore, we write KCl and not ClK. Are you following? Did you get the same answer? Very good. Here's another example. We have calcium, a metallic element which belongs to group 2. Therefore, its oxidation number is +2. And since this is metallic element, you can find it on the left side of the periodic table. Reacted to chlorine. Chlorine is a halogen, a non-metallic element with an oxidation number of -1. Therefore, you can find it on the right side of the periodic table. Do you follow? Very good. So what are we going to do next? So we have to write first the chemical symbol of each element involved, right? And then we have to make a superscript. Ano aton himuon nga superscript? The oxidation numbers of each of the elements involved. Do you follow? Okay, let's proceed. Ini siya ang oxidation number, diin mo na siya makita. Of course, sa imo man periodic table. Okay? And what are we going to do next? We have to follow the crisscross method. Since ari siya sa superscript, imuon mo siya nga subscript of the other element. Like for example, positive 2 is the superscript, the oxidation number of calcium. You have to transfer that as a subscript of fluorine. Okay? And so with negative 1, the oxidation number, the superscript of fluorine, you have to transfer that as a subscript of calcium. Do you follow? Very good. Therefore, we have calcium chloride as our new compound formed from the reaction of calcium and chlorine. And its chemical formula is written as CaCl2. Notice that there's no subscript of 1 adjacent to calcium, right? Because you don't have to write a subscript of 1. Remember that. And also take note that if you have the same oxidation number for both elements involved, you don't have to write anything as subscript. Do you get it? Very good. Now it's your turn to try. You have aluminum oxide. You have 30 seconds to answer this, and your timer starts now. Time is up. Let's see if you got it right. First thing that you should do is to determine what are the elements involved in this compound. So make sure that you have to have your positive half and your negative half. So in this case, your positive half is your metallic element, and that is aluminum, which belongs to group 3. And it follows that its oxidation number is positive 3. Make it as its superscript. Do you follow? Okay, very good. You have to do it also with your oxygen as non-metallic element with a negative oxidation number of negative 2. Okay, make it also as its superscript. And then what are you going to do next? You have to follow this crisscross method. Okay, so you have to transpose this superscript of positive 3 to a subscript of oxygen. Also with the superscript of oxygen, transpose that one as a subscript of aluminum. And there you go, Al2O3 without carrying the sign. Do you follow? Do not carry the sign of positive and negative, just the number. Okay? So our chemical formula for aluminum oxide is Al2O3. Did you get the same answer? Very good. Okay, now let's try to write a chemical formula out of 2 polyatomic ions forming compounds. Like for example, ammonium as the positive half of the chemical formula and sulfate as the negative half of the chemical formula. These are not existing as pure element, therefore you cannot find this on the list of elements in the periodic table. But don't you worry, because there is a list at the bottom of your periodic table. You can check that out. List of positive polyatomic ions as well as list of negative polyatomic ions with their corresponding oxidation number. Do you follow? Okay, well and good. Notice here that the polyatomic ions carry an oxidation number. But remember that this oxidation number does not represent only the element nearest to it, but it represents the polyatomic ion as a whole. Do you get it? Very good. Now let's see if you did get the same answer. Okay, our new compound is ammonium sulfate, and its chemical formula is written as NH42SO4. Nga may parenthesis diri. Kumbaga kagaina, ang oxidation number sang aton polyatomic ion represents the polyatomic ion as a whole. That is why we need to enclose this NH4 in a parenthesis before kita magbutang sang subscript na 2. Diin na naghalin ang subscript na 2 sa superscript sang SO4 because this 2 is the oxidation number of SO4 before the reaction without carrying its negative charge. However, SO4 is not enclosed in a parenthesis because the oxidation number of NH4 is +1. And remember that you don't need to write a subscript if it is 1. Do you follow? Well and good. I'm sharing you some list of some common chemical compounds with their chemical names, trade names, as well as their chemical formula, which you might have encountered on different commercial products that you might be using every day. Let's start with sodium bicarbonate, also known as baking soda. Its molecular formula is NaHCO3. It is a quick-acting antacid used to treat heartburn, indigestion, and upset stomach. Next, we have calcium oxychloride, also known as bleaching powder. Its molecular formula is CaOCl2. This compound is used for bleaching cotton and linen in textile industry and for bleaching wood pulp in paper industry. It is also used for bleaching washed clothes in doing laundry, and it is used for disinfecting drinking water supply to make it potable. Now let's proceed to hydrochloric acid or muriatic acid. Its molecular formula is HCl. This kind of compound in its concentrated form is used in regenerating ion exchange resins, building constructions, and dissolving rock in oil production. But also it is used as descaling, food additive, and gelatin production in its lower concentration form, of course. Now let's proceed to potassium hydroxide, also known as caustic soda. Its chemical formula is NaOH. This compound is used to manufacture soaps and variety of detergents used in homes and commercial applications. Sodium hydroxide also is used to help manufacture a variety of medicines and pharmaceutical products, from common pain relievers like aspirin to anticoagulants that can help to prevent blood clots, to cholesterol-reducing medications. Next is methane, or also known as marsh gas. Its chemical formula is CH4. Methane is a hydrocarbon that is a primary component of natural gas. Methane is also a greenhouse gas. Do you have an idea about that? Since it is one of the greenhouse gases, its presence in the atmosphere affects the Earth's temperature and climate system. Next is nitrous oxide, also known as laughing gas. Its molecular formula is N2O. It is a safe and effective sedative agent that is mixed with oxygen and inhaled through a small mask that fits over your nose to help you relax. Nitrous oxide, sometimes called a laughing gas, and is one option for your dentist to offer to make you help be comfortable during certain procedures. How about ethanol? Ethanol is also known as ethyl alcohol. Its chemical formula is C2H5OH. And ethanol is also known as grain alcohol or sometimes drinking alcohol because this is the only edible alcohol. Owing to its antibacterial and antifungal properties, it is used also in many hand sanitizers and medical wipes. It is an effective antiseptic and disinfectant. It is also a primary ingredient in many alcoholic drinks that are orally consumed for recreational purposes, and it acts as a psychoactive drug by reducing anxiety and creating a feeling of euphoria in humans. So I'm giving you this as an assignment. Please complete the table below for you to do the research to be well informed and familiar with some common chemical compounds that you might have encountered every day. Have you learned many things? Well, that's all for now. Thanks for watching. Till our next session.